Let's go to page 264. This is lesson 6-2. And the objective of this lesson is to simplify expressions involving radicals. So there are some properties of radicals. So on page 264, so the first is that when you have a nth root of a, b, this one you can go and separate into two separate radicals. Okay, so you can just separate. So when you have the product or the factors inside the radical, you can just separate. Okay, same thing with when you have division. When you have a over b, this you can separate into nth root of a, nth root of b. And the purpose of separating that so you can simplify each part individually. Okay, so let's go over some examples. Okay, example 1a, you have square root of 98. Now there are several ways you can do this kind of problem. So if you're good with perfect square numbers, you can separate this into square root of 49 and square root of 2. Okay, so break this into that. And then square root of 49 is 7, and square root of 2 would be square root of 2. Okay, so you can do it this way. Now if you don't know the perfect square number, then what you do is just go and use break it down into the prime factorization. So this you can divide by 2, so it'd be 49, and you can 7 and 7 divide by 7, you get 1. So again, 2. So this one means square root means you need to get two radicands to make it one integer. So these two radicand make it one integer, and the leftover stays over here. So you can do either method. Okay, 1b, you have cube root of 25 times cube root of 10. Okay, so what you want to do is you don't want to multiply out, because when you multiply, you make the number big, and you have to do the double work to make it smaller. So what you want to do, you can break these things down into smaller radicands. So this is cube root of 5, cube root of 5, right? Because 25 is 5 and 5. Okay? And 10, you can break into cube root of 5, cube root of 2, right? So again, 5 and 5 is 25, 5 and 2 is 10. And now you got three radicands. Notice you got cube root of 5, cube root of 5, cube root of 5, right? So the index is 3, means you need to get 3 of the same number to make into an integer. Okay? So again, the index tells you how many you need to have to make it into an integer. So these three radicands make it into an integer. And this is the leftover, so it would be just cube root of 2. Okay? So for this kind, you want to break into small bits and pieces, and then you can gather the radicands and make into integer. Okay, so example 1c. Okay, you have cube root of 81 over cube root of 8. So this one you can separate using the property 2. You can separate each one individually. Okay, and so this one you can go off to the side. You can do the prime factorization. So 81 can divide by 3. So it'd be 27 divided by 3, you get 9. Divide by 3, you get 3. Divide by 3, you get 1. Okay. So now the index is 3, means you need to get 3 of them. So you need to get 3 of the radicands to make an integer. So these 3 radicands make an integer. This is the leftover. So you're going to get cube root. Now make sure you have the index. Okay, so this 3 comes in here. Okay, now let's go and do the top. So you got the 8. So you need to go and do the cube root of 8. Okay, so you do the 8. So divide by 2, you get 4. Divide by 2, you get 2. Divide by 2, you get 1. Okay, so again, index is 3, means you need to get 3 radicands. You need to get 3 of them to make an integer. So again, index 3 means you need to get 3 of the same thing to make it into an integer. And so that's your answer. Okay, example 1d. You have square root of 60 over square root of 5. Now another thing you kind of have to look is that if you can reduce, if they have the same kind of number, so this is a radicand, this is a radicand, so they are the same kind of number, that means you can reduce. So both are divisible by 5, so you can divide by 5, you get 1, divide by 5, you get 12. Okay? So now you can go and simplify, right? Now square root of 1 is just 1, so you don't it doesn't do anything. So square root of 12, you can divide by 2, you get 6. Divide by 2, you get 3. Divide by 2, you get 1. So this one over here, again, square root means 2 radicands make an integer. And the leftover would be stay inside the square root. And over 1, you don't have to write anything over 1, right? Because over 1, you can just not write that. And that would be your answer. Okay. So if you can reduce, go and reduce it. The only time you don't reduce is that if the denominator is a perfect square, then you don't want to mess up your perfect square. Okay. Okay. Next, let's go to page 265, example 2a. Okay, you got square root of 2a squared b. Okay, so you can break that into small bits and pieces. So you got square root of 2 and a squared square root of b. Now, when you become more proficient, you don't have to do this step. You can just look and figure it out. Okay, so this one can square and square root cancel out, so it'd be just a. But remember, in this case, you have to put absolute value, right? When inside is already a square, you have to put absolute value. So that will take care of this part. Okay, now this is the leftover, so you can put it back together inside the square root. Okay, so these are the leftover inside, so you can leave it like that. Okay, example 2b, you got square root of 36 w cubed. So again, you want to break into perfect squares, so 36 would be just 36. W squared would be W2 and W, right? So again, the reason you want to do that, so this become a perfect square. Okay? So you always want to take out as much as you can for the perfect square so you can simplify the square root. So this would be 6, this would be W, and be square root of W. Okay? And now, okay, remember when you take the square root, so this is it. Now normally, because of square root, okay, it's not as a cube of here, so this is going to be, so this tells you that W cannot be negative, right? Because if W is negative, this would be not real. So we know from here that W is positive, and therefore if it's positive, you don't have to put absolute value. So over here, we don't know. Over here, it can be positive or negative, right? But over here, we know that it has to be a positive, because if W is negative, this will give you a negative, and it will give you unreal, not real. Okay, so that's the reason you don't have to. So when you know it's positive, you don't have to put absolute value. Okay, whereas over here, it can be positive or negative. That's where you have to put absolute value. Okay, again, because you cannot have a negative inside the square root. Okay, example 2c. Okay, you have cube root of x to the 5 over y to the 3. Okay, so you can go and separate each part. Okay, so you're going to have cube root of x to the 5, and you're going to have cube root of y to the 3. Okay, now over here, again, you can skip one step. You can skip this next step if you kind of become more proficient. So you have cube root of, you want to break into x cubed so that you can cancel out. Okay, so 5, there are 5 factors. So you want to break into 3 and 2 so that this become nice, right? You can simplify nicely. And so this will become x, and this is the leftover, and this becomes y. Okay, and so that's your answer. Okay, so you can learn how to break it into parts, and always break down the part that can simplify nicely. Okay, example 2d. Okay, you got square root of 4a squared plus 4b squared. So in this case, what you can do is you can factor out the 4. Okay, so you got a squared plus b squared. Okay, and then from here, again, from this part, the square root of, you also can do this, okay? Okay, break into 2 parts, and then this will become simplified into integer. Okay. So again, when you become more proficient, you can do more, you can cut down some steps. You can skip this step over here. Okay, from here, you can square root of 4 is 2, right? And this one this is not a perfect square. You can just leave it like that. Okay, let's go to example 3a. So instead of wasting time copying the problem, you can just go and apply the property tool and go and separate the top from the bottom. Okay. Now, when you have radicals, you're not allowed to have a radical in the denominator. So you need to find a way to get rid of the denominator. And the way to do that is, since you only have one, you need to multiply by another one on the bottom. So you need to multiply by one more to make into a nice integer. But when you multiply something on the bottom, you need to multiply same on the top, because square root of 3 over square root of 3 is 1, right? So when you multiply by 1, you're not changing anything. So now you got two of the same radicand. So these two radicand can make into integer 3. Okay, and the top, this is radicand, so you can multiply together into 15. Okay, so remember, you only can multiply or cancel out the same type of number. Okay, integer with integer, radicand with radicand. Okay, so 3b, okay, you got 4 over cube root of c. Okay, so now you have to get rid of the radicals. So to get rid of that, you need to have, notice the index is 3. So and you only got one of them, right? So you need to get 2 more. So you need to multiply by cube root of c, okay? So you need to get 3 of them. So you need to get 2 more. You got 1, so you need to get 2 more. Now, because you multiply by 2 more, so you need to get 2 more on the top, right? You need to do the same thing. So now, again, index is 3, so you need to get 3 of them to make it into an integer. So now this becomes a c, right? Now on the top, you multiply out, so it becomes cube root of c squared, right? Again, you only can multiply radicand with a radicand. Okay, so radicand times radicand, this gives you the inside, and the integer stays out here by itself. Okay, on page 266, example 4a, okay, you have square root of 53. Okay, so the books talk about tables, but now you're allowed to use calculator, so a lot easier if you use calculator. Okay, so you need to know how to use your calculator. Different calculator has a different key sequence. Okay, some calculator you have to enter the radical sign first, then the number. Okay, for my calculator, I have to enter the number first, and then I have to push the square root symbol. Okay, and the instruction says give decimal approximation. So now you got all these digits, so you have to run it off. When you run it off, it's approximation, because when you chop off digits, it becomes approximation. Okay, and so this is equal to 7.280109 whatever, right? Again, you don't have to do this step. I'm just writing down so you can follow what I'm doing. And you want to run it off to the hundreds, nearest hundreds. So this is where you're going to chop off. So you have to look at this point, this over here. If it's 4 or less, you just delete it. If 5 or more, you run it up. So in this case, your answer would be 7. So since you chop off, it's become approximation. So it'd be 7.28. Okay. Okay. Example 4b. Okay, you have cube root of 7100. So again, you got to know how to use your calculator. So 7100, and the cube root of that would be, so this would be 19.21997. Again, you can skip these steps, but I'm just showing you so you can follow what I'm doing. Okay, so two decimal place, right? The hundredths, right? So that's what you need to keep. So you have to look at this digit over here. So this is more than 5. This is 5 or more, so you have to run it up. So answer would be 19.22. Okay. So again, when it's 5 or more, you run up. If it's 4 or less, you just drop it off. So make sure you know how to do the rounding. Okay, example 5a. Again, you do an approximation. You got 4th root of 100. Okay. So get your calculator. So 100, 4th root. So this is equal to 3.16227 whatever, okay? And again, the instruction says to the nearest hundreds, okay? So that's what you need to chop off. And so this is 4 or less, so you just drop it off, so approximately to equal to 3.16. Okay, example 5b, you have cube root of 170 squared. Okay, so in this case, what you need to do is you have to square this first. So go 170, and I have a square button, so I can use that, square. Then I need to take the cube root of that. So cube root of that. So this is equal to 30.6878136, whatever, okay? Again, you don't have to do these steps, okay? So I'm just showing so you can follow what I'm doing. Okay, so you need to approximate to nearest hundreds. So that's what you're going to chop off. So you look over here. So this is 5 or more, so you have to run it up. So this will approximate to equal to 30.69.